So, coming to today's topics, we will be covering a few important concepts. As last week we had missed certain time. Today we'll be covering objects and classes. We will be learning about this keyword, how to create an object and how to create a class. We will learn about inheritance using some certain examples, and we will also learn how overriding works in inheritance. And coming to polymorphism, we will also learn about overloading and how polymorphism is useful. And we will also learn about encapsulation, wherein how based on different access members, private or public and protected, we are able to access different things. We will also learn about why we are using getters and setters during our encapsulation. And if time permits, we will also learn about interfaces. So these are, as you can see, these topics that I have mentioned are all concepts of the object-oriented programming. Uh, so coming to the first topic, objects and classes, we know that a class is nothing but a blueprint of the objects. So a class basically consists of two parts. It has the data members and it has the data methods, which is the so basically every class is consists of a state and a behavior, and these classes are used to model and create something called an object, which is the real life actualization or entity of that particular class. So to think of it, you can think that a class is like a concept, an object is the realization of that concept into an actual entity, a physical entity, and that physical entity can be manipulated. For example, a class can be something like a dog, and then any particular like pet that you have is the object of that class, because it is very so classes are very generic and object is a specific instance. So coming to a blueprint, this is the syntax of how we create a class in Java. So let me go ahead and open NetBeans. I am just going to be using the same Java session project. Yeah. So if we now go inside our package and take a look, we only have one particular file. So as we discussed before, this is our main file, wherein it consists our main class, which is the Java intro, and we know that this is the main class because it has the main method. So how do we define a class? So a class is nothing but this basic syntax that we have here. Public is a special keyword that we will be discussing soon when we are going to talk about encapsulation. And the basic syntax of a class is class name, and open and close the parentheses. As you can see in this example, yeah, as you can see in this example, a class dog has been created, and it has certain data members, which is the breed, age, and color. Breed is a string, age is an integer, and color is a string. And it also has certain behaviors, which are the methods created. For example, barking, hungry, and sleeping. Let me just check if it is recording correctly. Yeah. So coming to the same example again, we can see that yeah, in our case, we had the Java intro class. We had two data members, which is our integers test1 and test2, and we had only one method. We had two methods. One is our main method, and the second one was a print variable two method. So what exactly it does is that the JVM compiler or the Java compiler, what it does is the main class is extracted, and from the main class a main object is created, and inside the main object the main method is called, and that is the point of execution, the starting point of execution of our application. This is all done internally and it is not done by us. That is the whole reason why main class is important, and there can be only one main method, so that since it is all done by the compiler should not get confused if in case we have two multiple main methods, or if we have multiple classes with the main method. The JVM or Java compiler will not be able to understand which one to run. So to make sure that everything is working correctly, we have only one. Coming to a constructor. So let's go ahead and let's create a different class for our scenario. So if I go to my package, I can click on new Java class, and let's go ahead and create the same class. We'll call it dog. I'm just going to copy and paste all these members that we have created. So we have a public class dog, and we have all the variables inside of it. So we have the breed, age, and color, and we have the three methods. So now when we go ahead and we create an object, so now we know that dog is a concept. So to realize this concept, it can be done by creating a object. So let's go ahead and let's create a dog object in our main method. And I'm commenting out all the other code. If required, guys, please let me know. I can also publish this code on GitHub so that you guys can have easy access to it. So to the main way to create a particular object is by initializing the object as a new variable. So to do that, the basic syntax is the class name followed by the variable name, and then we equate it to the new and keyword. So new is a special keyword present in Java, which basically tells the compiler to create a new object. So we go ahead and after new, we have the same class name again, but instead of directly giving the class name, we call the constructor. So we will now talk about constructor and what constructor actually is. Constructor is actually a method that is present in the class, which we will be creating after discussing this. So if we want to actually create the object for this particular class, we would say dog. Let's call it puppy, or puppy equal to new dog. Since we don't have any particular constructor that we have created till now, we can just give the class name, and we can call the method like this with empty parameters with no input. So this is the by default constructor that is present in build, and what it says to the compiler is create a new object called puppy of the dog class. So now that we have a dog created with the name puppy, we can use all the functionality present inside this. So if we now go and we access it by saying, uh, by printing out the puppy name. See, as soon as I do, the compiler is already suggesting me all the different properties inside the puppy. The puppy has an age, the puppy has a breed, and the puppy has a color. And the puppy also has certain methods, which is the barking, hungry, and sleeping. Now, the other methods that we can see here are all methods that is coming directly from Java itself. Since it is an object, since it is a class, by default, certain methods are already present inside, which basically helps us to manipulate the data inside. So now if I go ahead and if I do something like puppy dot age, and if I save it and I try to run it, so what I'm doing is I have created a puppy of the dog class, and I'm printing out the puppy's age. As you can see, the value is 0. This is because in my class the values have never been initiated and have never been created. So we need a step wherein while creating the puppy, we are also able to modify the data we are giving to the puppy. So in this case, we want to modify the breed, the age, and the color. So to modify like the object created during creation, we use a special method called a constructor. So if you go back to our tutorial, we'll be able to see constructor. A constructor is nothing but each time the new object is created, a constructor will be invoked. The main rule of constructor is that they should have the same name as the class, and the constructor will basically allow us to do certain activities while the creation of the class. In this case, we have a puppy class, and you can see public puppy is present. Since this is a special method, since this is a special method, it does not have a return type. As you already know, methods have a return type, and it has a different signatures as part of the um, parameters or return types. So however, a constructor is a method that does not return anything because the object is being created. That is why we will not write any return type. So in our example, we will have a constructor called puppy. So let me just go ahead and create a empty constructor. So what this says is public dog, and it is empty for now. So in my public dog constructor, what I want to say is, while creating the dog, I want to get an input as my parameter called age, or let's call it yeah, let's call it age in caps. And I want to assign this age to this object's age. So to do that, we say age equals age. Now the ambiguous part comes when we are talking about two variables that are equating each other. Right now it is not giving me an error because they are of different names. However, if we have the same name, Java would not understand what the statement means. As you can see, already assignment to itself warning is being given and the assigned value is never used. So we as a developer also will not be able to understand when we write age equal to age. What it is saying is the the dog class internally has a variable called age. So that is the one in the left, and we are assigning it to age, which is the one we are getting in the constructor. The problem is, since they are of the same name, we are not able to distinguish and understand which age is being assigned to which. That is the reason we have a special keyword in Java called this. So when we do this dot age, what it refers to is the variable in line number 19. When this dot age is written, we know that the property from line number 19 is called, and the other age that is present is only existing inside the constructor since it is given as input in the parameter. Now, as we are giving the input in the parameter, we also need to give that as part of our input while creating the object. So in our example, let's call it 3. So what this means is we are creating a dog called puppy. That is the name of the dog, and we are creating it using the new keyword. And while creating, we are passing it the data of age 3. Now, when we try to print it out and I run the application, you'll be able to see that 3 is printed out, because now the object is created and my constructor is able to set my data inside my objects variables. Similarly, if we have a barking method, and inside our barking method, let's go ahead and print out something. Now to invoke this method, all we need to do is puppy dot barking. Now, when we try to print it out after our age, whatever the barking method behavior is, the barking behavior is executed. In this case, it is printing one line, woof woof. This is how we can, the dot operator is how we can access the properties of an object. We can, in this case, we are operating we are accessing the age property, and in this case, we are accessing the method barking. That is why we have the parentheses. Now, the barking method does not need any values inside in line 22. That is why we are not giving any parameters. If required, we can also give any parameters that we need, however we choose to. Now that we know what a constructor is and how we can create an object, we have learned about instantiation or initialization, which is done using the new keyword and calling the constructor. In this example, on the website, we can see puppy class is there, not dog. It's a different example. And in our main function, the puppy, my puppy is the name of the object of puppy class is called using the new puppy keyword, and the parameter given is Tommy. So in this case, in our constructor, we are taking the string name and we are printing out page name is name. We are trying to print this out. So now you can see that when we compile it, while creating, it will create the object and it will also print this line which says page name is Tommy. We also spoke about accessing variables. So we are accessing using the dot operator and the variable name, or if we have a method, we have the dot operator and the method name. This is another example wherein we have a puppy with a property puppy age, and in our constructor we have a set age method wherein age is given and puppy age is set to age. That is done by calling my puppy set age to. So in our example, instead of doing it this way, what we could have done is we could have had an empty constructor as before, and inside our empty constructor, after creating, let's say we are creating another variable called dog puppy2 equal to new dog. Now in this case, the puppy is created without age, And what we can do is we can say puppy2 dot set age and pass it the age. Now set age is a behavior method that we are creating like barking that is not currently present. So let's just go and create it. And in set age, we will take an int age. And the same thing that we have done in constructor, we are doing it here. So the only difference is constructor, when we are doing this action in the constructor, it is automatically done during the creation. So it has to be passed. However, if you don't want to pass it, then we are doing it in the set age method. So now if I copy and paste this line again, but instead of puppy age, I will call out puppy to age. You can see that puppy to age 1 has been printed. So if you want to give age, now we have two constructors, one with the age and one without the age. So now this basically gets us to a different topic which we'll be discussing later on in this recording. Now let's talk about inheritance. Now that we know what an object is and what how to create objects, now we will learn about inheritance. What inheritance basically is that there are multiple classes that are present in our application, and whenever we want a class to extend certain functionality of an existing class, we will use inheritance. This is what is also taught in a class diagram, wherein we have a class and it is inheriting all the members and properties of a different class. So to do that, let me just quickly give an example on the whiteboard. So let's say we have a class, and in our example, we have a class dog. And let's say we have another class called animal. Now, in our application, let's say we want the dog class to inherit all the properties of the animal class, and animal class might have different set of properties. So to do that, as you know, in class diagrams, we represent it like this. However, with a hollow triangle. If I can change, yeah. So what this actually means is the dog class inherits all the properties of the animal class. Now in our application, the way it is done in Java is by using the extends keyword. So as you can see, extends keyword basically allows us to inherit the properties of a class. In this example, in syntax, we can see we have a super class and there is a subclass. The subclass extends the superclass. This is how we use the inheritance property. So after the class name, we just write the extends keyword and we mention the class name. I hope you guys are able to still see my screen. Let me close the whiteboard and share my screen. Yeah. So the extends keyword is used to inherit the properties of a class, and the class super is created. And when we are creating a class sub, we are using the extends keyword with the super. So let's go ahead and recreate whatever we did in the whiteboard. So now we'll create a new class. We'll call this class animal. And inside our animal, we have an animal's, let's say every animal has a name and every animal has an age. And we are creating a method. um, let's just say get age and get the name. So these are two methods. I'm just auto generating, but you can write it manually also. So we basically Yeah, so we basically have two methods, get name and get age, which returns the name and age. So now that we have a class animal, in our dog, what we can do is instead of directly creating our age and set age, since we don't want any error, I'm commenting it out. I'm also commenting out my yeah, the method that I've created. Now what we can do is our class dog extends animal. So by doing this, automatically my errors are gone, and it can see that all the properties are from the animal class are directly coming into the dog. Now, to make sure that the functionality is done correctly, we also want to call the constructor of our superclass. So this might be required sometimes, this might not be required sometimes, but the way to do it is very similar to how we have the this keyword. We have something called the super keyword. So what super keyword does is it calls the constructor of the super and the method declaration. So by invoking this in like a method, it basically calls the constructor of the animal class. So let's go ahead and also to demonstrate this, let's create a constructor for the animal class, and let's say uh, animal is being created. And in my dog class constructor, we can say dog is being created. Now, when we in our intro, let's comment this out so we don't have any error. We don't want to play around with puppy 2, so I'm commenting it out. So while we are creating the dog, let me create puppy 2. Let's play around with puppy 2 now. So now when I run this application, we can see that the animal is being created line is coming directly from the constructor of the animal class, and then dog is being created is coming from the constructor of the dog class, and all the properties of the dog class of the animal class is inherited into dog. That is why age is coming by default 0. Although we don't have age in our dog class, I have commented the code out, it still exists because it is there in animal. So everything in animal is now inside my dog. So just to recap, we have spoken about classes, we have spoken about objects and how to create objects, we have spoken about inheritance, we have spoken about this keyword, we have spoken about super keyword. Now let us closely take a look at these two lines that we generated previously. We had two objects created. One was a dog with age 3, and one which is called puppy, and one was another dog called puppy 2 with no age given. So as you can see, both of them are calling the constructor. However, one constructor has the age and one constructor does not have the age. When we take a look at our class, we can see we have two constructors, one with the age, one without the age. So whenever we give the age, the top one is called. When we don't give the age, the bottom one is called. This is called overloading. Sorry, overriding. Over, just give me a minute. Yeah, overloading. Overloading basically occurs as a concept of polymorphism. Let us take a look at what polymorphism is. So polymorphism is a concept that was also spoken in the theory class, wherein one functionality can be modified and done in multiple ways, where one behavior can be altered and it can be done in multiple ways. And another example of polymorphism is using the plus sign. So, for example, whenever in my, let's say I am trying to print out a statement, let's say I have a print statement. And in my print statement, I am printing out 1 plus 2. When I run this application, I am getting 3. However, when I print out 1, when I print out my name is, and I print out Akshat, I am getting the string. So as you can see, we had two scenarios with the same plus sign, but in both the scenarios, the plus sign was behaving differently. In the first situation, plus sign is doing addition for me, wherein 1 plus 2 equal to 3. And in the second operation, the plus sign is acting as a concatenation for me. So my name is string is getting added to Akshat. So this is also an example of polymorphism, wherein the plus sign is exhibiting two behaviors. In the first one, it is exhibiting addition behavior, and in a second one, it is exhibiting the concatenation behavior. Similarly, in our example, we have two constructors with the same name, and polymorphism is being executed, and the method has been overloaded. What overloading means is that there is a method with the same name, but there are different signatures. By signatures, it can either be the return type or the parameters. In constructor scenario, we don't have return type. That is why the parameters are different, as you can see. So whenever I call dog as a constructor, I am able to, while creating a dog, like for example, when I create puppy 3, I have two constructors that I can call. Both of them are creating the dog for me, but they have this functionality or this action has been overloaded, and they are doing it differently. In one scenario, I am not providing the age, so by default it is 0. In the other scenario, I am providing the age, so it is taking and setting the age for me. Similar to the plus sign, my constructor is now polymorphic. It has two functionalities. It can either take the age from me and set it for me, or it cannot take the age from me and create an empty object. This is the concept of polymorphism. If we take our example, polymorphic, since the object passes is a test, and polymorphic in extension will also have certain functionalities. Let us take an example quickly of, yeah, the example that we did in class. We have a salary object and we have employee object. Mail check from the salary object and mail check from the employee object. So mail check is the method that is exhibiting polymorphic behavior based on where it is being called from. If it is called from salary method, salary object, S object, then it is saying calling mail check from the salary class. If it is being called from employee, it is the same thing, but the behavior is different, and it is saying it is calling from the employee class, since we're doing it from the E. Salary extends employee, just to understand the structure. So now that we have spoken about polymorphism, we also know that in our inheritance, for example, animal, animal has uh, let's say animal now has a method called, let's say, action. And what it does is it prints out action of an animal. Now we know that this action method from the animal class has been inherited by default into our dog class because it is extending the animal. So I can, in our example, what I can do is I can call the copy object dot action method. If we run it, by default, it is printing out action of an animal. Let me comment out the other code so we don't have any confusion in the output. So we need to create the object. Yeah. These lines are coming from the constructor. So constructor of the animal class, animal is being created, dot dot dot, dog is being created, dot dot dot. Once created, we have puppy ready. From puppy, we are calling the action method, and puppy, although is it's not there in dog class, it is coming from the animal class. Since puppy dot action gives us action of an animal, this behavior is coming from animal class. Now, what if there is a situation wherein we want this behavior to be present in dog, but it has to be done slightly differently? So I want an action method in my dog, but instead of saying action of an animal, I want it to say action of a dog. So whenever we have a situation, let's go back to our whiteboard. Yeah. So whenever we have a situation, I hope my screen is still visible. So if not, you guys can, I can also put the image of the whiteboard later on after we end the recording. So whenever we have a situation wherein the behavior from the super class, let's in this scenario, let's say we have action method is inherited onto the subclass. So super basically means parent and sub basically means child, but it has to be modified. So whenever we have a situation like this, wherein the action method is coming from the parent class, but it is slightly changed based on the behavior of this particular class. So all what it's basically saying is, although I am getting action method from the animal, hold on, I don't want it, I want to do it differently. So in a situation like this, we use a concept called overriding. Overriding occurs when something is inherited and given to the class, but it overrides that implementation with its own version. That is the reason it's called overriding. Let me go ahead and share my screen again. So if we take a look at our website, overriding basically means the ability to define a behavior that's specific to a subclass type, which means the subclass can implement a parent class method based on its own requirement. In object orientation, overriding means to override the functionality of the existing method. In the example here, we have the same animal class, and let's say animal has a move. We have created action, let's now call it move, and it is printing out animal can move. Same move method is present inside the dog class, but it is writing dog can walk and run. The difference that's happening is that although now dog, some people might think now dog has two move method, one from animal, one from dog. But we know that there are no two methods from based on overloading concept, because the signature is the same. Both of them are void, and both of them have no parameters, no input. So rather than if it was different, then you are right, it would have become overloading. But since they are the same signature, instead of overloading it, it has become overridden. It has overwritten this thing with this thing. Now, if in our puppy action, in our example, let's say, since it is extending animal, let us have our own void action, and let's say dogs can do anything. Already NetBeans is giving me an error saying that please use the override annotation. This is not required for Java syntax, but it basically tells the compiler that this method has been overridden. We will talk about annotations during the next session, what it is and how it helps us, because we will also cover certain concepts in our lab session. So now we know that action is being overwritten, and this is now functionality is going to change. Now when we do puppy.action and we print it, instead of saying animal can what was it animal action of an animal, it is saying dogs can do anything, because that method has been re-implemented and overwritten over the one coming from the superclass. This is called overriding. I hope like it's recording clearly and everybody is able to understand. Yeah. So now we have last one or two topics left for our discussion. One of them is polymorphism. As we discussed in the beginning, we spoke about the different concepts. To recap, we spoke about objects and classes, how to create the class, how to create an object. We've also covered this before, but this was just a recap. Similarly, we spoke about polymorphism, how one thing can be done in multiple ways. The example was that of a plus a symbol, and in another, in object orientation, we are using the concept of overloading, wherein one method written twice can do different things. The example we took was of a constructor that was doing two different things, because we also learned what a constructor was. After that, we spoke about inheritance. We already know how class diagrams are inheriting the properties in the theory class, and this is the implementation of inheritance using extends keyword in Java. Then we spoke about how the instance or object is created, how we are calling the method using the dot operator, how we are calling the properties using the dot operator, the member data. Now we are talking about another topic called encapsulation. So encapsulation is a very important part of object oriented concepts, which supports the single responsibility and separation of concerns principle. So, what single responsibility and separation of concerns principle state is that if an object is created, it has only one purpose. It has to do only one type of things that is related to itself. Either it will have data related to itself, or it will have certain behavior or methods related to itself. In our example, the animal class had a name and an age. So name and age are properties related to the animal itself. It had constructors get and these methods to get the name and age and the action related to the animal. Now, animal does not care about the dog class, animal does not care about the cat class. It is only talking about itself. This is what is meant by separation of concerns. It is not concerned about anything else, and single responsibility. It has only one responsibility, and that is the functionality of an animal. Similarly, for our dog, although our dog extends our animal, it is by definition an animal, yes, but it is only concerned with the dog. It has constructors for a dog for creating dogs. It has breed and color, which are specific to dog, not animal. Now, animal has no understanding of breed or color. Breed and color are solely responsibility of the dog class. And it has other methods like barking and hungry and sleeping, which are methods or behaviors of this particular dog. Now, animal does not know barking because an animal is very generic. Not all animals will bark. An animal does not know what is hungry or sleeping because that is only in the dog class. Action is something that is coming from animal, but the dog class was like, no, 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 I don't want this action. I want my own action. And it created and overwrote it use, by using its own action behavior, action method. This is overriding. This also we learned. Now, whenever we talk about encapsulation, we have to make sure that certain properties of the inherited classes, properties or behavior, as in state or methods, should not interfere with that of the ones inheriting. In this example, let us say this, we know that age and name by default are coming to dog since it is extending. Now, what if there is a scenario wherein we have a situation like int or let's say string. Now, this type can either be a mammal or it can be like the other kind that lays eggs. So there might be a situation where this scenario is not met or this scenario is not required. While talking about dog, although it has now has the type variable, since it is coming from animal, we might not want to talk about it. In any of our methods, we are not talking about it. So let's say we don't want this type to be present in our dog. That is done in encapsulation using something called access specifier or visibility specifiers. Access specifiers and visibility specifiers are concepts that we have already learned in our theory class. Let's go ahead and take a look at our website. Encapsulation is basically a mechanism of wrapping the data, which is our variables or the state, and the code acting on the data, which is our behavior or methods, together in a single unit. This we have already learned. This is what a capsule is, and this is the example professor gave in the theory class talking about a capsule, a medicine. Now, we never care about what is inside that medicine. We treat that medicine as one entity. We only talk about it from the outside world. We do not open it up. We do not take all the internal components out. We do not count all the containing items or the liquid. We don't care about it. We just treat the capsule as one thing. And it is very important encapsulation because these variables or whatever inside is hidden from the other classes and the outside world. This method is all this property is also known as data hiding. So encapsulation is basically a concept in object-oriented programming, a fundamental concept which allows us to actualize the concept of data hiding so that it is not able to interfere, the outside world is not able to interfere with its internal workings. In our example, let's take this example. Uh, Encapsulation test has been created, a class, and we see that all the data members present inside of it, such as name, id num, and age, are private. So this is what I was discussing in the beginning of the recording, wherein we have certain keywords like private, public. Now these keywords are what we write in Java that allow us to define the visibility of the particular entity, of the particular member. In our example, we can see that we have not given any of the values for public or private. So let's go ahead and make everything private. So name is private, age is private, type is private. We don't even need type. Name and age is private. Now when we go to our doc class, we can see that we are already getting an error. The error we are getting is age has private access in animal. So what private allowed us to do was we created the age property and name property, but it is privatized in our animal class. Although it is a dog is extending the animal, dog is inheriting from animal, it does no longer have access to that age variable. So when we inherit, dog will not have the age member. We do this because in some scenarios, we want certain things to be inherited and we don't want certain things to be inherited. So whenever we have members as private, they will not be inherited. However, to avoid this problem, we can make it public so that while inheriting, dog will be able to get that property and automatically the error is gone. Because in this scenario, the dog class will have the age variable but will not have the name variable because name is private. This is called encapsulation. So private and public, similarly, in our, let's say in our dog class, we are making the action method as private. As soon as I save this file, I am getting the error that action cannot be private because in animal it is private. Let me make it private here also. I'm still getting error because override no longer makes sense because it is private there. It is never being inherited. So it does not have to be overwritten. And immediately I'm getting a error in my main class saying that puppy.action method, although I'm invoking, it is private. I can no longer call it. So this is to demonstrate, this error is to demonstrate that methods can also be privatized, as in behaviors can also be privatized. So animal class might have certain behaviors that are public, which can be inherited and accessed from the outside world. and can have certain members or methods, which are behaviors that are private, that is very internal to animal itself. Although dog is extending or inheriting from animal, there might be a situation where certain things are not inherited since they are private. Similarly, in our main class, we can only invoke and access methods that are public, and that is the reason we are getting this error. Since action is private, it is no longer allowing us to call it. So let's go ahead and fix that by making the action method public. And even in our action animal class, we make sure it is public. It is always a good practice while creating objects and classes to make sure that we are specifying the visibility of that particular entity. That is the reason when we look at our files, we can see that our Java intro class is public, our dog class is public, and our animal class is public. If we make our classes private, then we can never create objects of those classes. Now, this is a very rare scenario where we'll be doing like that, but it is a possibility that the language allows us to do. Now, although a small concept, the last one that we'll be discussing today, although it is important to make certain things private, for example, name, what we can do is we can provide a safe way for the dog to talk to and change the name. And to do that, we have something called getters and setters. In this case, we have already created one public method called getName, which gives the name. So although I cannot do puppy.name, what I can do is puppy.getName. Now when I run it, it's not printing out anything because name is not a value that I have assigned. Similarly, to provide a safe way to set the value, we can have something called a setter. And let me go ahead and create that for the name, because name is the one that is private. The other one is public, so I'm not bothering about it. Now I have a public method called setName, which will take a name and set it into itself. We can know it. We know that it is setting into itself because this dot name equal to name means that this dot name private variable is being set to name, which is incoming variable in parameter. So to access this, to see that if this is working correctly, we can call puppy dot set name. Let's call it Tommy, and then we are calling the get name, which will give us Tommy. Puppy, yeah, is that created? Puppy action we don't need. Ooh, get name is not printing out anything. Okay. Yeah, so get name and set name are methods that are public, so they get inherited into our dog. However, let me just take a look. Let me call this simple constructor. I'm commenting all the unwanted code out. Okay, after creating puppy, I'll be able to. Okay, if we take a look at our code, super constructor is not doing anything. Oh, what is get name printing? Oh, get name is returning the string for me. So let me make it void to simplify it, and I will have a print statement inside. Rather than returning it, I will have the print statement that will print it out for me. So it's easier. Okay, this dot name. Make sure we don't. Yeah. So initially, when I try to get the name, it is null because it has never been set. Then I'm calling the set name to Tommy, and then when I'm getting it, I'm getting Tommy. So this is done so that although the variables are private in animal, the methods or the behaviors have become public. And that behavior is trickled down into the dog class due to inheritance. And from dog, I'm able to access the getter and setter safely. So that is the whole benefit of having getters and setters, so that they are able to control and have the proper necessary like security measure to stop unnecessary access from the outside world to the name property of animal class. Puppy is inheriting the animal class, and that is the reason puppy does never has the name property. However, puppy has a set name and get name property since it has come from the superclass, and that is the reason it is able to invoke the methods of set name and get name and easily modify or access the data if required. So this is the last topic that we discussed today. Just to recap, we spoke about classes, how we create classes. We spoke about the this keyword, and we spoke about objects and how we can create objects. We spoke about inheritance, how to extend the superclass into a subclass, and how we can invoke the constructor using the super keyword. We also learned about what the constructor is, and after we learned about constructor, we learned about polymorphism, which was nothing but how the plus sign works, or how multiple constructors can be created for same functionality. We also know that the multiple methods can be, it doesn't have to be a constructor. Any method can be polymorphic and overloaded to rewrite the implementation. Similarly, we also learned about overriding, telling the inherited class to override the implemented method, whichever is not required. And we also learned about encapsulation by giving public and private access and seeing the errors. And we learned how to safely deal with it using getters and setters. So that's it for today's session, guys. If you have any questions, please contact me during my work hours, or you can just ping me a message anytime on Teams. And whenever possible, I would immediately give you guys a reply, and we can connect for a quick session if you have any questions. Please also make sure that from next time you are in class, if you have any particular specific questions, or you're attending it online, attending the Java session online, so that you are able to get more uh, understanding and easy access to the content. Thank you, everyone. Have a good day.